Are x-intercepts same as zeros? $1 million question. Let's try to find the differences between zeros and x-intercept and understand them better before even solving quadratic equations. Let's enjoy this journey of learning. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider differences between zeros and x-intercepts. Well, most students who start learning about zeros of quadratic functions or solution of quadratic equations, they land up with many related terms. Two of them, which are most confusing, are zeros and x-intercepts. Are they same things or are they different? This is what we are going to discuss in this particular video. I hope you find it interesting. Well, they have some similarities, but they are not exactly same. They are very different. Let us see how x-intercept and zeros are same and how are they different. Perfect. So let's begin with understanding what x-intercept is. Okay. Now, with reference to the quadratic function, as you know, there could be two scenarios for x-intercepts. One case could be that the parabola just touches and bounces back, or it may just cross the x-axis at 2 points. You get the idea. Right. I've taken these two cases because parabolas could open up or down. Perfect. So x-intercepts, what are these? These are the points on the x-axis, right? So this is your x-axis, that's the y-axis. We normally write f of x, right? Or y. So points on the x-axis like these, where the curve touches. So here it touches, right? Or across. So those are the x-intercepts. Well, we do refer to these two things also as zeros, right? So these are also, we can say, zeros. Why are they zeros? Because the value of the function is 0 at x-intercept. Perfect. And therefore, most students think that zeros and x-intercepts are exactly same thing. Right? Now, let us look at the differences, right? And then try to understand what are zeros, correct? Well, now, as you can see very clearly, the two types of x-intercepts are different, right? For example, type 1, where it just touches and bounces back, right? So let me write bounces back after touching, right? So in that case, strictly speaking, this will happen if we have two zeros. Well, what I'm trying to say is, let's say we have minus x square, right, equals to 0. So at this time, we have two roots, x times x. You get the idea. So whenever it bounces back, we have two zeros. So zeros have multiplicity. Or order. Sometimes we write order. So that means number of zeros could be different, right? So in this case, there is only one x-intercept, but there are two zeros when it bounces back. In the case when it crosses, like shown in the second graph, there is 1 0, 1 0, and one x-intercept, one x-intercept, right? So you understand that. Right? So as you can see, one of the major differences that zeros have multiplicity or order. At an x-intercept, we may have multiple zeros. For example, if I have x cube, right? In that case, you know the graph of x cube, how will it look like? Well, it goes like a saddle point. Do you see that? So here we have multiplicity of 3. So there are 3 zeros at origin for x cube. However, there's only one x-intercept. You see that? So number of x-intercepts and number of zeros is different. So definitely they are very different, right? Now that brings us to a very important point, and that is we see that all the three types of x-intercept shown are showing a different behavior of the curve, right? This behavior is decided by the zeros. So we can add one more characteristics to zeros, that zeros predict behavior at x-intercept. Make sense? So if there is only one zero, it will cross. So we see this is like having 1 0, right? If there are two zeros, it touches and bounces back, right? If there are three zeros, in that case, what happens? It goes like a saddle point. You see that? Very important. Goes like a saddle point. The x-axis is actually a tangent at this particular point. Perfect. Now here, everything which you see is related with zeros and x-intercepts. And when we talk about coordinate plane x and y, we are talking about set of real numbers, right? So these are the zeros which have real values. So here we have learned couple of things. Now let me summarize these things on a new page, and then we'll move further and see what are more differences between zeros and x-intercepts. So what we learned just now between zeros and x-intercepts are that x-intercepts are points where curve touches or crosses x-axis, correct? Now, these x-intercepts are also zeros, since at this point f of x is equal to 0 at x-intercept. Is that clear to you? But in addition, what we learned here was that zeros have order or multiplicity. And they decide behavior of curve at x-intercept. Is that clear to you? All this we have seen on xy plane, right? So that's what we learned. Behavior really means that we had three types of zeros, which we just saw here. The one which turns, right? The one which just crosses, and the one which may be like a cubic function. So the behavior is that there are two zeros. We normally say even number of zeros. So if there are even number of zeros, 2, 4, 6, 8, in that case there is turn. If there is a linear zero, then they cross. But if they are all more than one, right, greater than one, in that case it will be like a saddle point on the x-axis. Is that clear to you? So this is on real plane. Now there's one more difference, which do you know what is that? Well, you remember in quadratic equations, when we are finding zeros, we use a formula, right? So normally the equation is that ax square plus bx plus c equals to 0 means x is equal to minus b plus minus square root of b square minus 4ac over 2a, correct? Now in this equation, you learn that if b square minus 4ac is 0, then we have two zeros at the same point. They are not distinct, right? So that is the first case, correct? So in this case, b square minus 4ac equals to 0. But if b square minus 4ac is greater than 0, then we have two distinct roots, two distinct x-intercepts, two different x-intercepts, right? Now what happens when b square minus 4ac is less than 0? In that case, what happens? No real roots, right? So we can say no x-intercepts, correct? However, there are two zeros, two solutions. So what we have is two zeros, and these zeros are imaginary. So x-intercepts are only the real solutions for a quadratic equation. However, quadratic equations can have imaginary roots, and those are those zeros, always in conjugate pairs, always two plus minus. You get the whole idea. So this is kind of important to understand. Zeros could be real or imaginary. Perfect. So now I think you are well equipped to understand zeros of quadratic functions. Now in our exercise, while finding zeros of quadratic functions, if not mentioned, will only work in the domain of real numbers. You get the whole idea, right? Will work in the domain of only real numbers, correct? So that's kind of important for us to understand. And with that, let's begin this playlist on solving quadratic equation, rather finding zeros for a quadratic equation in the domain of real numbers. I hope it makes sense. Thank you and all the best.